Hi, this is Tom, amateur reader call sign N8FDY, and today it's time for another meter review. And this time it's going to be an old meter. This is not the box that came in, this is not the case that came with it. I bought this case at Amazon, but it's a Fluke 189. This Fluke 189 was discontinued about 16 years ago. I was able to get this as new old stock open box from a place in Texas. So it was obviously they did used. I think they took it out of the box to show somebody, but it's in very good shape. It was cosmetically looked like brand new, and all the measurements met the specifications. You'll see that in the review. Now we have, this did not come with it either, but I put these Fluke with the retractable category 4 protectors in there with it, and of course the thermocouple and the little alligator clips that go with these. So anyway, that is not what you'll get in the box, but since you can't buy this new anyway, you never know what you'll get in the box. I'm not recommending you go out and buy one, but one of the reasons I'm reviewing this is because I think this is the best user interface meter Fluke ever built. It works really well. It was a good meter for its day. 20 years ago it was a good meter. It's still pretty good. And anyway, let's show you what it does. I really like that it has separate volts and millivolts for AC and DC. Modern meters, you always have to screw around with pushing the button, switching it from AC to DC. And this is just right on the rotary switch. Same thing for currents. It's AC and DC right on the rotary switch, so you don't have to fool around with pushing buttons. And it has a setup function very similar to the EV Blog 121 GW, if you saw that review. Lots of things can be customized, so you don't have to hold a button down while you turn it on to get the power off. You can just set it up in here. Anyway, we'll start out with showing you what the features of this meter are. This meter's third-party safety tested by UL and CSA. It's a category 3 1000 volt and a category 4 600 volt. It's a true RMS 100 kilohertz bandwidth. It's a 0.025% basic DC accuracy. It has a large display with dual parameter readouts. It has built-in data logging with time of day. You can view stored readings on the meter. It has a min and max and timestamp function. Its peak capture is about 250 microseconds. It has relative mode, and you can get an optional infrared connection to a PC. All right, now we can show you some voltages. First, we're going to start out with this little voltage reference I got off of Amazon. And like all of these little things I have, I measured them with my Keithley DMM 6500, which has been recently calibrated. So this starts out at 2.5005. We get 2.5002. Here is 5.0009. And we get 5.0003. So it's a little low. Here's 7.5016. And we get 7.501. Here's 10.015. And this shows up as 10.000. This is 1.414 millivolts, and it reads it as 1.048. Here's 5.0288 millivolts, and it reads it as 5.040. Here's 10.0086, and it reads it as 10.022. Here's 25.0425, and we get 25.058. Here is 50.0338 millivolts, and 50.0557. Here's 100.0225, and it reads it as 100.02. Here's 250.021, and it reads it as 250.00. Here's 500.028, reads it as 4.9991. Reads it as 499.97. Here's 1.000014 volts, and it reads it as 0.9999. Here's 1.50003, and it reads it as 1.4999. Here's 2.00002, and it reads it as 1.9998. Here is 2.49977, and it reads it as 2.4995. Well, you can see some of the voltages are a tiny bit lower than what read on the Keithley. So just for good measure, here's the 5 volts off the DMM check, and it's 4.9992. Very close. Now we'll switch to AC voltages. And the AC voltage is 4.9991. Again, very close. For more voltage readings and more detail, there's a written review. That review has the link in the description of this video. Now let's look at some of the other readings I took on the bench with this meter. Well, as you can see by the green, all the measurements met the specifications as stated in the manual. The accuracy in the higher millivolt range is good, really good, and then the lower voltage range is good. Once you get over 50 volts, it kind of drops down a lot. So it's good for more the transistor-based projects, really not accuracy for the tube-based, because it's really a lot less accurate on the higher voltages, according to the specifications. Now, when you compare the readings, though, they're still pretty good, and that's not bad for at least a 16-year-old meter. The input impedance for the DC volts range was 11 megaohms, and for the millivolts range, it was 10 megaohms, which is pretty typical for all these meters. As you can see by the green, all the AC voltages I measured met the specifications as stated in the manual. For measuring AC voltages, the minus 3 dB point was at 222 kilohertz. So this meter could definitely measure audio frequency level voltages and some low IF frequencies. Okay, this meter can measure AC plus DC, true RMS. So I'm using my arbitrary waveform generator to give it a 3 volt AC, as you can see here. It's close to 3 volts as we can get it. And 2 volts DC. And again, as close as 2 volts as we can get it. And now we're going to show you the AC plus DC. So there's the AC DC is 3.604. Now, the way you compute it is you take the AC voltage and square it, add it to the square root of the DC voltage, and then you take the square root of that. And that's what we did on this calculator. The calculator says it should be 3.6055, and we get 3.6060. So that's really close. Let's take a look at some other AC plus DC measurements we did on the bench. As you can see by the green, all the readings taken met the specifications as stated in the manual. It is pretty handy to have it do the math for you to figure out true RMS between AC and DC. So that's limited application, but it sure comes in handy when you need it. First, we're going to do some AC current with the DMM check. What's really nice about this meter is it has the AC milliamps and DC milliamps separate positions on the meter. I really like that. Here's 1 milliamp, 100 hertz square wave on the DMM check, and it comes out as 1 milliamp. Wow, 1.006. Pretty good. Well, while we're here, let's check the DC milliamps. 9.96. Here's 0.89 microamps, and it reads it as 9.8 microamps. Well, it's really hard for a meter to be accurate at its very lowest edge of the range. Here's 9.21 microamps, and it reads it as 9.31. Here's 99 microamps, and it reads it as 99.14. Here's 131.8 microamps, and it reads it as 131.98. Pretty close. Here's 1 milliamp, and it reads it as 1.008. Here's 9.98 milliamps. It reads it as 9.96. Here's 99.4 milliamps. It reads it as 99.42. Well, let's look at some other current measurements we made on the bench earlier. As you can see by the green, all the measurements taken met the specifications as stated in the manual. It is interesting that the AC current is the least accuracy specification, and then that's followed by the DC amps, which is 0.5%, and the microamps are 0.25%, and the best accuracy specifications are the milliamps. The shunt resistors, we had 0.055 for the amps. We had 1.856 for the milliamps, and we had 100.89 for the microamps. This is very typical of these type of meters. Well, first we can compare the accuracy specifications of this meter to the other Flukes I have tested. And this is for the voltage and current. Well, as you can see, it seems like price does make a difference with Fluke on accuracy. So this was somewhat of a flagship 20 years ago, but as you can see, the 289 pretty much beats it in accuracy specifications in almost every way. And just a cautionary note, if you ever think of buying the Fluke 17B Max, don't buy it, because it's not if you're buying it for accuracy, because it has definitely the lowest accuracy specifications of all the Fluke meters I've tested. Now we can compare the accuracy specifications of this meter to its cohort of 60,000 and 50,000 count meters. Now the red names mean meters that have not met all their accuracy specifications, and the red lettering inside the boxes showing the accuracy specification means that the meter missed one of its readings in that specification. So with that, we'll go on to look at where the 189 kind of fits, and it doesn't have the best accuracy in anything but one area for the voltage and current, and in two areas it has the worst accuracy specification. So really, if the more accurate meters for voltage and current, you got the Bryman, the Greenlee, and of course the Fluke 289. Let's move on to testing resistance measurements. Well, let's zero out the leads. All right, 0.18. There we go, zeroed out. Here's 1.004 ohms. It reads it as 1.08. Here's 10.007 ohms. Reads it as 10.2827. Here's 100.069. Reads it as 100.26. Like most meters, except for the high-end Brymans, when you put it in relative or delta mode, it automatically turns off the auto ranging. You get back to auto ranging by first pressing the rel key, and that will put you into the rel percent mode. So then you have to press the rel key again, and that will put you into normal mode. Then you have even more to do, is you have to press the yellow key, and then you have to press the cancel button, which actually has written on it HZ%MS, but you see in yellow above it says cancel, and now you're back to normal. 1.0001 kilo ohms, and we get 1.000 about 8 kilo ohms. Pretty close. 10.002, and we get 10.006. Pretty close. 100.02 kilo ohms, and we get 100.1 kilo ohms. This is 0.9970 mega ohms. 0.996. 9.97 mega ohms. We get 9.98. 100.3. 100.2. 100.1. Make up your mind, buddy. Now it's 100. 99. How long will it? If I wait long enough, will you go down to 0? That's all right. It's staying at 99.9. Well, most of the meters we've tested can't read the 100 mega ohm resistor, so that's pretty good. Let's look at these values that we did on the bench earlier and compare it to the Keithley. Well, as you can see by the green, all the resistance measurements met the specifications stated in the manual. And as a bonus, it read the 100 mega ohm resistor, which many of the meters I've tested can't go that high. The test voltages used in the resistance ranges where the low was 5.161 volts. In the medium ranges, it was 0.995 volts. And then it went back up in the high ranges to 2.166 volts. Let's do some capacitance measurement. Let's see what kind of stray capacitance we got on these leads. Well, we got about 90 microfarads. So we're going to have to roll that out. Usually we don't use the two smaller capacitors, the 10 and the 100 picofarads, but let's just see what we get here. That's what I thought. We get 0. Well, that's pretty good. We get pretty close, 97. Most meters don't do that good. Now we get to the 1 nanofarad, 1.005 nanofarad to be exact. Here's 1.005, and it reads it as 1.003. We'll give it. Oh, no, it's... I don't know if it's the age of this meter, but it sure drifts. Well, here's 9.921, and we get 10.01. Yeah, it kind of drifts a lot. Okay. We're getting low battery. That's what's wrong. Well, you can see how we change the batteries. And we'll be back with more batteries. All right, we're back with some batteries. And here's my handy Klein combination screwdriver. Okay, so you turn those each about 45 degrees. And there you go. Here's the battery compartment, and the fuses are accessible. So these batteries came with the meter. I sure hope they aren't from 16 years ago, but they could be. But so much for those. We're going to use our tried and true, trusted energizers. You can always trust the bunny. Well, like I said, the battery door is held with two plastic fasteners that you turn counterclockwise 45 degrees to unlock. The battery compartment holds the 4 AA batteries, and it also gives you access to the fuses. There's an 11 amp fuse and a 440 milliamp fuse. Very convenient. This is 9.921 nanofarads. And it gets it as 1003. That's okay. Here's 99.51 nano. And we get 99.6, so that's pretty good. Here's 1.09 microfarads. And that's dancing around 1.09. Here's a 10.294. And it reads it as 11. Here's 112.2. And it reads it as 113. Here's 944.5. It reads it as 1008. Let's check out the measurements I took earlier in the bench and see how they compare. Well, as you can see by the green, all the readings met the specifications as stated in the manual. It is unusual to have consistent accuracy specifications throughout this range of the capacitance. Now we're going to look at the resistance and capacitance accuracy specifications as compared to other Fluke meters. And as you can see, the resistance specifications are pretty good. They're actually better in a couple of cases than 289. Of course, then they're a little worse than the 289. Actually, the worst of everything when you get a little in the higher values. So it's a little weird, but that's okay. The 87V Max dominates capacitance specifications. Well, for the resistance accuracy specifications, at least on the low end of the resistance, the 189 and the Unity 181A dominate in the accuracy specifications. But every place else, it's sort of spread all over. So my gather is that it must be hard for these higher-end meters to get really consistent accuracy in all these capacitance ranges and high resistance ranges. So you just got to sort of pick the one you like and hope that it's good in this end. Well, now it's time for some diode checks. And our favorite diodes, LEDs. The red lit up, and you can see the forward voltage. The yellow lit up, and you can see the forward voltage. No chirping. Oh, the green showed up, and you can see the forward voltage. No chirping on any of these. So we'll see what the diodes do. Well, you can see the forward voltage, and it did chirp. Let's listen closely so you can see what that chirp sounds like. So it's very short and a little quiet, but it's there. Here's a small signal diode, and it chirped. Here's the rectifier diode, and it chirped. So this meter pretty much acts like most Fluke meters. So they've been doing it this way for a long time. Let's take a look at the bench measurements and the voltages and currents used for the diode testing. The maximum diode voltage was 5.1613 volts, and the maximum diode current for testing is 0.999 milliamps. So, pretty good. Well, now it's time for continuity checks. The leads that came with this meter were the old plastic stiff leads, which I sold off at a Hamfest already. So I, of course, put some of those other, they're not the gold-plated leads, because, you know, I'm not going to waste the gold-plated leads on this. But it was the better Fluke leads that had the silicon and the retractable Cat 4 protectors. But, like we test all continuity and all the meters, we're going to use the Probe Master gold-plated silicon leads. Wow, that buzzer sounds really strange. Makes it sound like it's not latched, but I think it is latched. It just has this weird tweedle to it. I don't like that. I wonder if there's a way to change it. Well, anyway, here we go. It's kind of hard to tell with that tweedly sound. I don't like that. Well, your speed demons aren't going to like it, but it's okay, but I don't really like that sound. I have to see if I can change that. Well, like I said, most of you won't be buying one of these anyway. I just wanted to show you something from, 20 years ago that I think was really a good design, and I really wish they would have kept it, or at least kept something like it, a newer version of it. It's pretty convenient to operate. It's very nice that it has the setup menu, and there's lots of things you can change with that setup menu. It's a little cryptic, so you need the manual with you. But most meters that use the secondary display like that are kind of cryptic. The ones that aren't as cryptic are the graphic meters, but yeah, you don't want, that gets into a lot of expense. The Unity, the UT181A, that that's definitely cheaper than this meter. So, and it has the setup menu, which is nice. But still, this is a convenient, nice meter that runs off of AA's. So if you own one of these, you probably want to keep it. And if you see one on eBay at a really good price that looks like a really good shape, I'm surprised that it's held up and kept its tolerances for... well, I guess I'm not surprised, because the Fluke 179 I have that's over 20 years old is still meets its specifications. So, anyway, let's look at the pros and cons. Well, the good parts of this meter. This meter is at least 16 years old, and all the measurements taken met the accuracy specifications as stated in the manual. Another good thing is you can go into setup mode without turning off the meter, because most meters you have to turn it off, then hold a button down, then turn it on. But this one you don't have to do that. This has almost as much customizations as the EV Blog 121GW. And I really like being able to customize the meter. Well, some of the not so good sides of this meter. It was discontinued around 2008, so it's really impossible to get one unless you can find a new old stock somewhere that somebody discovered, or you find a used one in a good condition. So it's not going to be easy to find. And the PC interface is an extra cost option, and there's a special part you need to make it to work on this meter, and I couldn't find that part anywhere because I could have used the interfaces I got for the 289 for this, but the special modified plastic thing I only found in one place, and those guys wanted me to buy a whole meter package which included that, and I didn't want to buy another one of those meters. I already had one, so I did not test any of the data communications part of this meter. I hope you enjoyed this review. Sorry it wasn't on a meter that would be more available to buy, but this meter fascinates me, and I'm so disappointed that Fluke stopped making meters that work like this exactly. I think it's a really good user interface, and you can see how some companies have copied that user interface, and I'd say there's a lot of other meters that are close, but I mean, almost nobody separates out the currents and voltages by AC/DC on the rotary dial, and I just find that so convenient. You know where you're at, you don't have to mess with pushing buttons, and I like that it has the setup instead of the pushing and holding a button when you turn it on, because if you want 3 of those features on, it's pretty hard to hold all 3 buttons and turn it on. Anyway, I hope you enjoyed this. This is Tom, N8FDY, saying 73, and take it easy.